I'll show how a transformer is used to create a DC power supply. This configuration of diodes is called a bridge rectifier. It converts the AC signal to DC, flipping the negative part of the sine wave to positive. The capacitor then smooths out the wave curves, resulting in a mostly constant DC voltage. The R1 resistor in this circuit represents the load that would be connected to this power supply. As you can see, once the power supply has fully started up, it provides 5 volts. If you did the math on the turns ratio, you might be wondering why it's not the same. It's not the same because all the extra conversion circuitry and the load reduces the voltage. If you measure what's coming right out of the secondary winding, you'll get just about the same amount as calculated. Here's a program I wrote to calculate the resulting voltage peak at the secondary. The other calculation will be useful later. Here's what the output would look like if you used a smaller value capacitor. And here's what it's like if there's no capacitor. Here's a circuit with 2 secondary windings, one that will provide 12 volts to the load and another that will provide 5 volts. By the way, sometimes the bridge rectifier comes self-contained in a cylindrical package like this, or usually in a square package. You can eliminate 2 of the diodes if you use a center tap transformer with the center tap connected to ground. By using another capacitor in this arrangement, you can create a voltage doubler. The voltage across the load is a little higher than the expected 10 volts, but this would be because the turns ratio creates more than 5 volts at the secondary. By the way, with all these power supplies, you might want to use a voltage regulator before the load. Remember, the transformer transforms using a fixed ratio, so if the input AC voltage varies, so will the output. The power coming to your house can fluctuate. Plus, different loads on the supply can change the provided voltage. A voltage regulator can ensure, within reason, a truly constant voltage. Also, these are pretty much the simplest designs. Power supplies in most desktop computers, for example, are much more complicated. Please subscribe, like, share, comment, etc. And if you click subscribe, click the bell to receive notifications of future videos.